Hi and welcome to statistics. The first thing I'd like to do is talk a little bit about what statistics is because it's very different from other kinds of math that you may have taken. It's a way of actually analyzing information that you collect about people, things, whatever. Statistics are around us in the media, on TV, online, in the news. You see them all over. And you'll also encounter them in a lot of majors or jobs that you might be thinking about. Education, social work, health fields, and lots of other areas too. In this class, we're going to talk about where this information comes from, how it's properly analyzed, and how to decide if you should trust information that you encounter. The first chapter is going to feel not like a math class at all. We're going to start with some vocabulary because statistics vocabulary is different from other math classes. We're going to talk about the proper way to conduct a study and how to evaluate information that you encounter that's presented by others. So statistics then is the collection and analysis of this information. When you're doing a study, the variable is what you're trying to measure. For example, if I'm doing a study and I want to measure people's heights, the data is the information that you've actually collected. So in that example, my data would be all the heights of all the different people that I surveyed. Some vocabulary that you need to be very familiar with is population versus sample. The population is the whole group that you're talking about. So if I want to talk about all women in the United States, versus a sample, which is a smaller group that I actually collect data from. So it's not usually practical to collect data from every woman in the entire country. Instead, I might have a sample of 5,000 women that I collect information from in order to learn more about women in general. So the population would be all women in the United States, and the sample would be the 5,000 that I actually collected data from. That's what we do when we do statistics. We collect data from a sample. If you actually collect data from the entire population, then that's called a census, like the U.S. Census that happens once every 10 years. These don't happen very often because usually the population is too large to do a full-scale study of. There are two main types of statistics. There are descriptive statistics, where you really just look at the data from the sample and talk about what you found. And then there's inferential statistics, which is where you take that information from the sample and determine what that tells you about the whole population. What kinds of things are you allowed to say about the whole population based on just that sample? We're going to start off with descriptive statistics in the first half of the course, and then we'll move on to inferential statistics after that. When you come across statistics that you need to interpret or think about, there are some important things that you need to consider, and we're going to talk about each one of these a little bit more in depth. The first thing that you need to think about is pretty basic. It's just the context. What do these numbers stand for, and what situation are you talking about? So a set of data might talk about heart rates. So you have a list of numbers, and you know that those numbers are heart rates and that they're measured in beats per minute, and you know that they were collected from men of a certain age. The second thing that you need to think about is the source of the information. Where did this information come from, and is there some reason that it might be biased, or does it probably come from an objective source? For example, drug companies who stand to profit, you don't generally want to trust data that comes from studies that they have done. Another thing that you need to think about is the sampling method. How did they choose the people that they included in the study? And was this a random sampling? We're going to come back and talk about this later in the chapter in much more detail, but for now, just keep in mind that samples need to be random to truly be representative of the population. And especially voluntary response samples are something to be wary of. These are samples where someone gets to choose whether to participate or not. For example, if they see a TV show that has you call in to vote, or if you have to log on to a website in order to vote, anything where you have to go decide to participate tends to skew the results because people tend to have to care pretty strongly one way or another in order to actually go to the trouble to answer those surveys. And so you tend not to get a real representative sample of the broad spectrum of response types. Another thing to think about is whether the conclusions that they've drawn are valid. For example, there was a study that was actually done in which it seemed that people who drink coffee were more likely to develop cancer. The thing you have to watch out for is you should not speculate then that the coffee is what's causing the cancer, because when they did some more follow-up studies on this, they found that what was actually happening was that the people who drink coffee were more likely to engage in other risky behaviors like drinking, smoking, things like that. And so those tended to be the things that actually contributed to the cancer. So you have to be very careful that they're not making false inferences about causes or things like that. We call this correlation versus causation. Just because two things are correlated does not mean that one actually caused the other. Statistical significance merely means, are the results clear enough that they could not have happened by chance? So if you find that just a little bit over half of the people in your sample have a particular preference, that doesn't necessarily mean that over half of the whole country would. That could easily happen by chance. On the other hand, if my sample had 75% preferring a certain thing, then that probably means that over half of the country would, because the results are extreme enough. It doesn't always have to be that extreme, and throughout the whole semester we'll be talking about how you know certain things, and at the end of the semester we'll be much more specific about how you know if results are statistically significant. But for now, just keep in mind that they are statistically significant if those results indicate something that probably did not happen by chance. And then the final thing to think about is practical significance. Statistical significance may mean that something didn't happen by chance, but it doesn't mean that it was extreme enough for anyone to care. So you should also think about whether these results matter to the population. For example, a study that correlates coffee drinking to a higher risk of cancer could have practical significance for people who drink lots of coffee, and they may want to discuss this with their doctor. So practical significance is different from statistical significance because the statistical significance is more numerical importance, and practical implications are, do these really matter to people who read about this information?